Hi everyone, we're going to have a quick look at equations of motion now using question number 7 from exercise 6.03. So the question says a monorail train begins from rest, so straight away I will make a note that the initial velocity equals 0. Travels with a uniform acceleration of 1.2 meters per second squared. And then it says what will be the speed of the monorail after 30 seconds. So that's a way of saying t equals 30 seconds. They also want to know how far it will have travelled. So we will assume quite reasonably that x0 equals 0. In other words, the monorail begins from the origin of our coordinate system, and to start off it said find the speed of the train, so v equals u plus a times t. We noted that u equaled 0, acceleration is 1.2 multiplied by 30, so we could go 1.2 times 30 and we get 36 meters per second. That's fine, but it might be nice, thinking of this as 36 meters divided by 1 second, it might be nice to remember that there are 3,600 seconds in 1 hour, and that there is 1 kilometre in same as 1,000 meters. So that would mean that seconds cancels as a unit, that meters cancels as a unit, and I'll be left with the unit of distance being kilometres divided by the unit of time, hours. Now effectively this means multiply by 3.6. So I'll just take my previous answer, multiply by 3.6, and I get 129.6. So that's approximately 130 kilometres per hour, 0 to 130 in 30 seconds. That's the monorail for you. Now it also said to calculate how far the thing had travelled, so this is x equals ut plus 1/2 at squared. That's the first thing that springs to mind. U was 0, time was 30, of course that's nothing. 1/2, acceleration was 1.2, time was 30, that's nothing of course. Let's go straight to the calculator. Now 0.5 by 1.2 by 30 squared, we get 540 meters. Is that the only way we could have done that? No, not at all. We could have as an alternative used x equaled u plus v divided by 2 multiplied by t. We know that u was 0. V was 36 using SI units over 2, and time was 30. We'll end up with 18 times 30, and I think you can see that 3 times 18 is 54. Of course we have to get the same answer, otherwise we've broken physics. Don't want to do that. So there we have a pretty straightforward example of how to use our equations of motion. I've used 2 alternate versions here for displacement. Obviously we only have to do one of them, and that's a nice, neat little introduction to the equations of motion.